Morning, Matthew.
Hello, good morning,
How
Dr.
are you?
Pandey. Good, good. I just had a question on specifically the homework um, number 5.
Number five is which one? Is that the one with the monument or something?
Yeah, the monument.
Yeah, that's a harder one. I'll talk about that in the class as well. But yeah, yeah, let's talk about this, right? So let me open up the whiteboard here, uh, and let me just give you the hint, right? I'll still let you work
Okay.
on.
Yeah, I was trying to compare it to one of the lecture examples,
Yeah, the
the
lecture
one with the pipe.
it's the one with the pipe though is vertical curve, so that won't be
Yeah,
directly
that's why I
comparable, right?
was
So
a
that
little
so that's
confused.
so you have to be careful about that, right? So make
Hmm.
sure that you are focusing on like differentiating clearly between if it's a horizontal curve problem or a vertical curve problem. So let's see if we can draw that. So this is what it is, right? So there is like a high, so P line is basically a center line, highway center line.
Hmm.
And then you have another line that like another direct. So this is what the two tangents look like, right? And
Yeah.
then you have the curve. I'm trying to draw the curves here. And then these are connected, like so you're gonna draw like a little curve here, right? Ah, this is bad. I'm trying to let's see. So about arrow, just it won't be a line. Let me just try and do that a little bit better job. Okay. So let's see. So let me draw like a curve thing here, right? So let's say this is what it looks like. Okay. Uh, gonna just do give me 1 second, okay? I'm getting used to this. Okay. So your curve will look something like this. So it's gonna start from here,
Hmm.
right? And it's gonna be so this is gonna be a horizontal circular curve, right? And then if you draw it
Yeah.
back to the center, maybe the center looks something like this, right? So in these problems, it's always good for you to kind of draw, and then this is a circular arc, okay? I know it doesn't look like one, but make sure that you know, right?
Hmm.
So and so one thing about these highways is that if you are having a center line and you have a right of way width of 100 feet, what basically that means is that Caltrans or whatever agency is involved, they're going to acquire 50 feet on one side and 50 feet on the other side of the
That's
center
center
line,
line. Yeah.
right? So there
Hmm.
will so this is going to be the center line curve, but then there will be another curve that's kind of like maybe exactly 50 feet away from this. That'll look something like this. And then obviously after that, it's going to be another line from here to here. Okay. And then do you see? So
Hmm.
these will be these outside lines are going to be exactly 50 feet away. This is going to be exactly 50 feet away. And so that's going to be sort of your inside boundary of where the roadways right of way will end, right? So in
Yeah.
these types of problem, it's always helpful to kind of draw these things to back to the center and trying to kind of establish some things that hey, what do we know and what do we not know? So if you think about the distance from, I'm going to draw a little circle here or a little diamond. So if you kind of think about this point here, from here all the way to oops, wait. So start from this point all the way to this point, right? What's going to be the distance between these 2 points? Do we know?
No.
No, we don't know, but let's so we need to figure out the radius of the curve, right? That's what the problem is asking. We need to figure out the radius of the curve that's being asked of us. So if this distance from here to here, maybe I should record it, right? So maybe I can share it with other students as well. So give me 1 second, okay? Oh, it is recording. That's perfect. Okay. So yeah. So in these types of problem, it's helpful for us to have like what they're asking, right? They're asking for radius. So if this is the center of the curve and you go all the way up to the center line, that's going to be your alignment radius.
Yeah.
Right. So let's call it R. Let's denote it to be. Let's write down. This will be, if I want to type some text here. So this is going to be, this distance would be, let's call it capital R. But if I only want to measure from here to here, if I only want to measure from this point right here all the way up to this point, do you know what that would be?
Well, technically it'd be R minus the 50 feet, right?
Exactly. This is R minus
Yeah.
50, right? So that's good. So we know that. So this is good. So we know that this is going to be R minus 50. So I'm going to just put that here as a text. I'm going to say, okay, this is going to be R minus 50. Oops, sorry. Okay. So this is R minus 50 from just from here to here. Now think about the problem says you don't want monument to interfere with the right of way. Right. So now think about what you can do. Like, so let's say if your monument was located I'm going to try to put that monument here. If your monument was located here, is it interfering with the right of way? Like, do you see that star as the monument?
Yeah.
No, but is it interfering with the right of way? Is it inside the right of way?
Oh, wait, no.
It's not, right? Because your right of way ends here. So, and obviously, if you put it here, that's going to be problematic, right?
Yeah.
You cannot put it here because that will be inside the right of way. So what they're asking is draw the curve with largest radius such that the monument does not interfere with the right of way, right? So what does that tell you? Where would you put that monument then? Like, where would you put your right of way's outside edge so that you're creating the largest possible radius, but you're not having your monument be inside the right of way? What do you think? Where do you think the monument should go?
Like on the inner part of the triangle, right?
Exactly. So it should go right exactly at the outer edge of the right of way.
Yeah.
That's good, right? So these are the kind of things you have to think about when you review these problems, is that what does the geometry look like? I'm going to move it a little bit. I'm going to obviously move it but let's move it over here. And exactly on the outer edge of the right of way. So this is where the monument has to be. If this is where the monument has to be, you can start kind of building some triangles and see if you can make some information here. And let's see. Welcome to your new whiteboard. Okay. Okay. So let's think about if I draw this back to the center. So if I take a line and draw a line back to the center, this distance was also obviously would be R minus 50 as well, right? If you connect the tangent. Okay, now this is where it gets interesting, is that, what might be useful is kind of trying to create some triangles and see if there is some relationships that you can exploit and so forth, right? So I'm going to try to see if I draw a perpendicular because there are some distances that I'm given, right, in the problem. So let's see if
Yeah.
I know that. So I'm going to draw this line right here. Let's say this line is perpendicular. Oops. Let's say I draw a perpendicular. It doesn't look like it, but let's just assume this is perpendicular to the radius. Okay. Do we know anything about distance between this point, the center? Let's call it O, point O. Let's call it point O. So distance between point O and this perpendicular. Do we know? Let's call this perpendicular letter P. So do we know the distance OP?
No.
We don't. Oh,
Well,
maybe we do. I mean, do we know that in terms of R? Maybe, like, do we know the
yeah.
relationship? So you have to go and look back at the problem statement. I'm going to pull it up. Give me 1 second, okay?
Yeah.
Try to get it here.
Because it gives the original monument location. So
Right.
it says it's 106 feet. So is it R minus 106 feet, or?
That's exactly what it would be.
Okay.
Yes, that's right. So OP is going to be R minus 106. That's nice, right? So OP will be R minus 106. That's wonderful. Okay. What else? What else do we know? So so we know another thing, right? On this triangle, we know R minus 50. We know R minus 106. And do we know anything about this side of this triangle? Right. So we remember I gave you a hint about like the other problem in the where you can draw it back to the center and trying to find the angles. Here, I don't know if angle will be helpful, but there are other things that may potentially be helpful. Do we know this distance in any terms or any kind of? Remember, this is still perpendicular to the radius. So would this be parallel to any line here? So, I'm trying to find, like, let's call the monument letter M, right? So let's call the monument letter M. So if you have M, so yeah, I'm trying to figure out what MP would be. So OM would be obviously, so if I look at OM.
The problem statement gives the distance. It says 200 feet, but it gives that angle of 120. So.
Right. So basically what you know is like this angle is 120. So if I draw it out, right, let's see. So they tell us that this angle here is 120, right? Right, this angle is 120. So if this angle is 120, you know that this angle would be what? I'm asking you about this full angle. This angle here. Do you know what this angle would be?
The same.
Not
Would it be
quite the same, right? Because it's a quadrilateral. So this angle, do you know this angle?
It'd be 90, right?
90, right? Because these are angles between tangent and so this is where I think, remember the formulas I showed you in the chapter, like, how T is equal to R tangent delta over 2, and there were a bunch of formulas about, so I think this is where those things can come in handy, not the formula by themselves, but how these formulas were derived. Right?
Okay.
So if you know this, that's good. So if this is 90, this is 120. So do we know what this would be? This angle would be? So if you look at this quadrilateral, right? So I'm going to try to change the color. Focus on this quadrilateral. Okay. You can probably tell me what this angle will be, right?
Yeah. But so 90, 30, right? Or
60, right? So this whole 60, angle would be 60 degrees, right? And then the circles are usually like, they are not usually, they are always always submit. So if you draw a line from here, if I draw a line from here, from the center back to this point right here, then we know what angle would this be, right? It'll exactly bisect this, right? So if I want to find just this angle, do I know what this angle will be? The half of that? Because this is going to be symmetrical, right? If I create O to
Yeah.
the pi, so let's call this point pi. Let's call this point pi. From O to pi, what would that look like?
O to PI would be um, 60 or no, 30 times or oh sorry.
No, but see, yeah, you can figure it
Or
out. But like,
yeah.
so this is 30 degrees, right? So this is 30 degrees, and we know what is
Mhm.
O to P. This is, let's call it PT. So if I say, okay, this is my PT, right? This is PT. So OPIPT, that's the triangle I want you to kind of think about a little bit. So if you think about the triangle OPI and PT, right? OPI and PT, we know at least one side, right? We know O to PT is what distance is O to PT.
Um,
And we don't know the distance, obviously, but we know it
yeah,
in terms of R, right? What
it
is
would be R minus um
no O to PT?
O to PT. So uh R plus the 106, right?
No, see, that's the thing.
Oh
PT is the
yeah.
center line, right?
Mhm.
From O to PT will just be radius, right? Radius of the curve,
Oh, the whole radius, yeah.
right? Because remember, we are not subtracting anything, we're not adding anything. We're just saying this is not the inside lane. So for PT is the center line. So we define these PC value, I mean PC point of curvature, point of tangency from the center line of the alignment. So O to PT will simply be R. But if you look at OPIPT, can I say something like, your PI to PT would be, can I figure out what PI to PT would be?
Yeah. It would just be it would still be the outer radius, right?
Yeah, PI to PT is nothing but the tangent, right?
Mhm.
Right? It's the tangent length. And we know what tangent is for a circular arc. That is T times R, I mean, sorry, R times, ah, that's the formula, right? Does that make sense to you? PI to
Mhm.
PT, it's basically tangent. PI to PT is the tangent. So PI to PT. So PI to PT will be just R times tangent 60 over 2, which is tangent 30. So you can figure out PI to PT. Now, is there any way, and I know my drawing is kind of off here, and maybe I can use AI to clear it up. I don't know. But let's figure out, do we know anything that can help us now? If I know PI to PT, is there anything that can help me figure out what M to P is going to be?
Um, the value of PI to PT, well, you could use the value of PI to PT to find that the value M to P, right? Because we're given that distance from
Yeah, and then these are
the
all so.
PI
And then this
PI
is the
to the
90
monument.
degree angle. Yeah, yeah, exactly. That's exactly what
Yeah.
you're going to do. So I'll let you figure out. Don't yeah. So say it after, like, so think about it a couple of minutes. See if you can now solve the problem, because again, you have to find the radius. That's the goal. And then I'll give you some big picture hint. Uh,
Okay.
So I know it doesn't look like a rectangle, but this is a rectangle because both like this M to P is a perpendicular. MP is a perpendicular on O to PT, and then obviously radius and our tangent should have a 90-degree angle. So this is a rectangle. So if you think about this rectangle, you should be able to at least figure out MP in terms of, R.
Mhm.
Perpendicular to. So your goal is to kind of figure out all sides of a triangle in the form of one variable, because then you can apply the Pythagorean theorem to kind of solve for that one variable. So that's what you have to think about. Like, can we get all the sides? Now, in some other examples, like the one that you will do with the railroad in the other homework problem, there you can get both two sides and then the middle angle. You can find the angle by doing by trying to find just two sides of a triangle. Here you don't have a good thing about like good knowledge about the angle, but you can use information from this to figure out all sides of the triangle OMP in terms of R. And then once you know it, you can apply the Pythagorean theorem. So in these types of problems, the best bet is to kind of create the center point and draw the radius around the center point, and then try to see for which triangles do you know either some angles or some sides in the form of one variable. Make use of the information like what's the tangent length and things like that, and then just go from there. That's usually is the best bet, is to try to draw the center first, connect the curve to the center, find everything in terms of radius. Typically, the unknown variable is radius. So see if you can find some angle and two sides, or some either angle and two sides, or figure out maybe all three sides and then apply the Pythagorean theorem or something. That's usually is the best bet.